Exactly, I can go for manually. The problem is the number of analysis become more. There should be 3 analyses. Sample 1 with 2, 1 with 3, 2 with 3. Which means there are 3 samples mean 3 different tests. Suppose 5. How many? This 5C2. 5C2 means 10. So 10 t-tests you have to perform. So in order to avoid this problem, Fisher introduced a concept known as the ANOVA, which have the ability to do the normal sector. But in order to conduct the ANOVA, there should be some assumptions. That one of the assumptions of ANOVA, basically there are 4 assumptions. The basic assumption is data should follow the normal distribution. As you all know, normal distribution is a probability distribution. Here is about categorical variable, it won't follow normal distribution. Now the problem is you can't go for ANOVA, which is the case of non-parametric or categorical variables, because we violate the assumptions of ANOVA. In that situation, we have to go for the corresponding non-parametric test. So usually the ANOVA, we are using 3 main basic designs. Among that, 2 are the most commonly used. They are the CRD and RBD. What is CRD? Anyone can explain? Completely randomized design. One was randomized block design. What's the difference between these two? Just like I'm not going for the deeper.
Blocking completely identical animals.
Okay, you are correct. Basic difference. As a layman words, the basic difference is, of course, there is a randomization because there are 3 basic principles for this side. They are randomization, multiplication, and local count. Randomization means randomly assigning each treatment in order to reduce the what? Bias. Multiplication means you have to repeat the number of treatments in order to get accurate result. Now the last one is important, localization. What is a local count? Local control. You have to define it from the term itself. Local control means you are controlling to whom? Local. I'm coming to that. You are controlling to the environmental conditions. Explain. The difference is CRT is applied only for lab situation. So your experimental should be homogeneous condition. So you can apply CRT in a field situation. The problem is it is not homogeneous. The external factors can influence your experiment. So these are the basic differences between CRT and RT. Okay, in order to avoid this heterogeneity, we are converting field into blocks. The technique is known as the local control. Okay, now coming to our session. Corresponding to CRT, the non-parametric version is known as the Kruskal-Wallis test. Okay. Now corresponding to RBD, non-parametric version is, which I am not included in the session, but I will say the name of that test. Yeah. It's a Friedman test. So Kruskal-Wallis corresponding to CRT, Friedman test is corresponding to RBD. So that is the difference. Now the second difference is, that is the main point in which everyone makes a mistake. You can apply Kruskal-Wallis test in which definitely it should be more than 2 samples. Otherwise, you can simply go for a reinforcement of man-made. Now, your more than 2 samples should be independent in nature. Because if you have n number of samples, n should be independent. That is the situation in which you recommend the Kruskal-Wallis. Whereas Friedman, it should be related samples. That is, all your samples are dependent. And that is the difference between these two. First one is, it is CRT and RBD. Second one is for dependent, one is for independent. Independent is mainly go for the Kruskal-Wallis test, whereas the related sample should go for the Friedman. Okay. Now coming to the Kruskal-Wallis test, you have one data file which is known as the KW bar test. So can you please import that file? Remember, it is also a CSV file. So the format of importing is go to file, import data from the text.
Kruskal-Wallis 1 ANOVA തന്നെ 1 ANOVA നമ്മൾ കൗണ്ടിൽ പറയുന്നില്ല. ട്രീറ്റ്മെന്റ് നമ്മൾ റിപ്പീറ്റഡ് ANOVA ഇതായിട്ട് പറയുകയല്ലേ.
That's why there should be related. Repeated means the same thing should be a repeated number. So that's why it is related.
ഒരു CRP RBD question.
No, that is the version. As I told you, for every parameter there should be one parameter. So similarly,
RBD നമുക്ക് അത് repeated ANOVA ചെയ്യണം. 1 ANOVA ചെയ്താൽ പോരാ.
actually RBD is a 2way, not 1 way. 1 ANOVA is CRP. 2-way ANOVA means, why it is 2-way means, you already created blocking in your field. So that block should create a variable. That's why it is a 2-way ANOVA. Repeated ANOVA means the experiment is repeated in different times. So that will affect the dependence. So in parametric case, repeated ANOVA and RBD are different. The analysis is also different. But in non-parametric, actually it is a limitation. In non-parametric, you can relate to some buffer treatment, and it is another situation with buffer discussions. So please import the data.
Sir, in Excel format?
No, it's in a CSV format. So you have to go for file, import data from the text base.
Of text.
Okay, so this is your data. Now, one important thing, how to prepare the data. That is very important in the case of Pascal analysis. Now, can you see the data and tell me what are the situation? What is actually this experiment?
Different types of drugs, sir.
Yeah,
The
how many
amount
types
of-
drugs are there? You have to check it out in data. Then
No.
Three types. Then denote it as drug A, B,
A, B,
C.
C.
And your dependent variable is
Pain. Pain.
So we subscribed these three drugs into a patient and measured their amount of pain. Okay, now we have to identify which drug will be the best in order to recommend reduces pain. So that's the objective question. Okay, now why I am performing question over here? Why you should go for a question? Because there are more than 2 drugs. Suppose you have only 2 drugs, A and B. There is no need of go for question. You simply go for it. Which does you recommend? Because you are planning. Planning from glucose. Glucose, right? Only 2. Planning is also 2. Is it dependent or independent? This is a drug A and a drug B. So they are different. Sorry, independent. Okay. If drug A before and after means it is
It is
independent.
independent.
So here it is independent and more than 2 also. So that's why I choose Kruskal analysis. Okay. Then preparing data is, this is A, which is repeating up to 10. That is for 10 patients we recommended drug A. Similarly, for 10 patients we recommended B and C. And we need to identify which drug will be. Clear? How to prepare the data? Any doubt? Okay, so in this case, you need to define your H node. So H node is, there is no difference between the 3 drugs. Alternative is, there is a difference between the drugs. Now, to perform the function for Kruskal is Kruskal dot test. So last case it is Wilcox dot test. Similarly here, Kruskal dot test. Now, this one, Y followed by your categorical variable. In this case, your dependent variable is the pain followed by this is your categorical variable. So this is one of the formulas. You got it. Pain is your actual data, that is dependent variable. That should followed by drug, that is your categorical variable. Okay. Followed by data equal to KW. We got the result. First, check which parameter. First thing, check which parameter. No, first you have to check the degrees of freedom. How many drugs you have?
3.
3. So degrees of freedom? 2. 3 minus 1, 2. So you need to check whether degrees of freedom is 2 or not. If it is 2 means that is acceptable. Next. You got a chi-square value, here also p-value. So p-value is significant, which indicates physical values test is significant. So we reject the hypothesis that there is no difference between. So we concluded that there is a difference between variables. Now, next question is which drug will be used? Which drug will be used? For that, what we have to go?
Pairwise test.
We have to go for the pairwise test. Actually, up to Pascal value, you can perform it in SPSS. You can also go for Friedman test in SPSS. But beyond that, it is not available in SPSS. So why we should go for pairwise analysis means because I need to answer which drug will be best. So I need to compare each two drugs separately. So there are usually two tests are available to perform the post-hook analysis. Either you can go for a dumb test or you can go for a in-person test. Okay. Then I'm starting with the done test. That function is available in the library FSM. So I need to call the library FSM. Okay. Then done test is the function. Within that, pain followed by drug. Then data equal to KW test. Method equal to BH is the body fluid correction. That is the p-value correction. Okay. Have you got the result?
You
No.
need to first install that package it is asking.
You already installed it.
FSA, no.
No.
It is asking. Yes, received.
Not a value.
Then what is your
64. See. Windows.
Thanks, done, sir.
Okay, so all of you got the analysis.
This one you have done. First you have to install R, then RStudio. Both you have to do. I have done this. R.
Run it.
Already installed.
The bonus function. So you have to look at the P adjusted. See, is it significant or not significant?
Is it about more than?
This one,
Yes.
significant.
No, not significant.
This 1.6
Point one is such
minus 1.
yeah.
So it is 0.16. So it is not significant. Means the effect of drug A and B are the same. A with the C.
Significant.
It is significant, which means there is a difference between drug A and C. Now, B with the C.
Significant.
Significant. So, which drug will be the best?
B with C.
B to C.
B to C.
Which is more significant.
C is the best drug, right?
Because
here,
with the A and C
A
also,
B
with
are
B
on
also.
par. There is no difference. The only drug which contributing a significant difference is the
C.
So, C will be the. So that's how we identify which drug will be. So don't stop the analysis up to the Kruskal value. You have to go for the pairwise analysis so that you can clearly identify which drug will be the best. Now that's from the gun test. You can also perform the another post-hoc test, that is one of the Wilcox test. So it is pairwise Wilcox drug test. It is to do the pairwise analysis. Now there it gives you what? This is known as a p-value method. See, listen. In both post-hoc analysis, the outcome will be the different. You can't expect the same outcome from each test. Okay. So you have to choose either that test or Wilcox test. Now, if you are performing Wilcoxon test, your result will be a matrix. So matrix is you have to read it as like that: A with the B, A with the C. Here, B with the C. What is the p-value for A with the B? It is 0.06. It is not significant. So there is no difference between drug A and B. Whereas coming to A with the C, it is 3.2 compared to -5. It is less than 0.01. So there is a difference between drug A and C. Coming to B with the C, that is also different. So from this study also I can say that the C will be. Do you think right? Or move on to last session?
We'll go to the last section. Last section.
Last session. So far it's good. Any doubt? Any doubts? The situation? The only thing I say again and repeating the same thing. You need to don't need to by heart any code because now the code is with you. Now we can edit this. So only thing you have to learn from this session is what is the role of each function or how to prepare the data. What is the situation in which you can recommend a particular analysis? Because in statistics, that situation is very, very important. According to the type of your data and the situation, you need to pick the analysis. So that is very important. Because anyone can perform the analysis nowadays. Because these things are easily available. Of course, you can go to the ChatGPT, that is also creating a code. So there is no need of studying these things. But you need to identify the situation in which we can recommend a test. And from that test, how we can go for the interpretation. That is very, very important. Because especially if you are looking for any journal publication, those people are very interested about your interpretation skill. Because they already know that anyone can perform the analysis. You can simply go to some table, figure from analysis. But how you interpret that particular result for your study, that is important. Okay. So you need to develop that kind of skill. Now let's move on to
So
the
what's the meaning of p-value adjustment method DH?
there is a different probability adjustment method. One of the most common is the Boniferoni correction. So that Boniferoni correction is Now, let's move on to the last session, that is the correlation. So, what is the correlation?
Relationship between
In studying a relationship between two or more than two variables. Okay. Not for this session. This is for the curiosity I am asking. What is the regression analysis?
cause and effect. Cause
There
and
is a
effect.
cause and effect. Regression is also study the relationship, but there will go for a functional relationship. In functional relationship means we need to identify
The regression means
what
cause and
kind of
effect.
function. It can be linear function or a non-linear function. So for that we require the variable to two segments like the cause and effect or independent and dependent. Whereas in the case of correlation, there is nothing like that. It simply study the relationship between the variables, two or more than two variables. As there involves only two variables, we call it as a simple correlation. More than two means multiple correlation. Now, there are three types of correlations generally, actually more than three, but nowadays we are mainly recommending about three. They are, first one, called Pearson correlation, then Spearman correlation, and more. Kendall coefficient of concordance. Now, as far as concerned, the last two are very important because we are basically dealing about the categorical variables. Okay, because called Pearson is applicable only for the continuous variable, that is for the measurable data. Whereas Spearman and Kendall will be useful for the categorical. Now, what is the range of correlation coefficient?
-1.
This -1 to
Plus
+1. What is this -1 +1 indicate? Okay, it's a complete negative. We call it as a strong negative. When its approaches to -1, when its approaches to +1 indicate there is a strong positive relation. What do you mean by strong positive relation? What is that positive stands for? When one variable is increases, another variable is also increases. Or you can say to reverse it. As one decline, another is also decline. In these two situations, it is a positive relation. Whereas negative relation means one increases, second one is decreasing. So the opposite thing. That's why it is a negative relation. Okay. Now coming to Spearman, it is known as the Pearson correlation for the ranked variable. So in this case, we are dealing about the ranked variable or categorical variable. Then ranges is also same as the -1 to +1. Okay. Now there is a question for you. What's the question? So here in line number 51, we conducted a cooking competition. There were 10 participants are involved. And how many judges are there?
3.
There were 3 judges given marks of the 10 participants. Now I have to check whether these 3 judges having any relationship or not. Why can't I go for Pearson for this data?
What's it?
Why we can't go for a Pearson for this data? It's a ordinal data because the judges are given the rank or mark out of 10. So it is not a measurable one. So that's why we recommended a Spearman over here. Okay, then could you please import that data? That is the same data file, but you need to import sheet 2 data. So data management, at the time of importing, please click as sheet. And we require these two libraries also. Okay, GG, core plot and descriptors. GG, core plot and descriptors.
I have only one data management. Sheet 2. Sheet 2 or sheet 1? Sheet 2, go to sheet 2. You type sheet 2. It will come. Go here.
Please install these two libraries, GG, core plot and descriptors. Core plot. Okay.
I am facing the problem.
What happened?
RStudio. I have installed again.
Okay. Did you install R? Is it
First
working?
install.
Is it working?
Then RStudio.
The problem is you need to reinstall it. Before, first you have to uninstall this one because it's a previous one. Now, before that I need to check whether your R is working properly or not. Just open that R. Yeah. It's working properly. Now you have to uninstall the previous RStudio version. Then you have to install it again. That's why usually the procedure is first you have to install R followed by RStudio. But in your case, the problem is you uninstall R, so that link is already lost.
So first we have
Okay, so we have to uninstall RStudio also.
first
Then again we have to install.
install R.
No need. Uninstall RStudio only.
Sir, it is asking for restart R prior to install. Can I click yes?
No.
If I want to download the Excel വേണം.
Which is this software? Detach.
Which one? This one?
You're installing.
Desk tools.
Your desk tools.
On the top they have mentioned no library required for that. That's one.
Moving to the line number 257. Listen, 257. First, I will define a variable CORR. So just we can give any name. Okay. Now the function is core. COR is the function for getting the correlations, but that should inside the round function because I need to round the correlated values. Otherwise, it will give you the 8 decimal value usually by default. So in order to reduce that thing, inside the round function core, data management is my data. Now you need to specify what method equal to spearman because by default it is a Pearson correlation. But we required a spearman, so I changed method equal to spearman. Any doubt in that line?
No.
I'm starting with a round function because I need to round the correlation value to 2 decimal. Then core is the function for getting the correlation. By default it will go for the core Pearson, but we require spearman. That's why I am specified method equal to spearman. Then followed by 2. Now you have to run 258. You will get the correlation value. Okay, have you got the matrix? Yes or no? Why all the diagonal values are 1? Right? Always diagonal values are 1.
Same to same.
Same to same. There is a correlational variable with itself. Then why the upper and lower diagonal values are same? There is correlation between x and y is same as y and x. But in the case of regression, it won't be the same. Because regressions are two types, forward regression and backward
Backward
regression. Forward regression means y with x, y is the dependent, x is the independent, whereas reverse means x will becomes the dependent and y becomes the independent. So So in the case of regression, these two values are not same. Okay. But in the case of correlation, there won't be any difference like y and x. It is x and y is same as y and x. So that's why the upper and lower diagonal values remain the same. Now we have to look at which one having the highest correlation. Okay. So the highest value we got is 0.96, that is J2 with the J3. So the highest relationship between the two judges, Q and J3, got the highest value as 0.96. So this matrix is known as the correlation coefficient matrix. But usually in the paper, you will also see there is some star notation. Have you noticed? What is the star notation? So we need to check the significance of correlation. Which test? That's the test. For checking the significance of correlation. Usually we use the t-test is for checking the significance. But in R, there is an easy method to check the significance. For that, we require the library ggcorrelog. Actually, this library is for getting the correlogram. What is the correlogram? Correlogram. Okay, what is the scatter diagram? Scatter plot. Have you heard this name first time? Scatter diagram. As if from the time itself we can define it. Scatter diagram. The scatteredness. Okay, look at the scatteredness, how we can say two variables are related or not. Okay, there will be more scatteredness means the variables are independent. Well, all the points are accumulated in a line, in a straight line, the relationship will be more. So that is the use of scatter diagram. What is a correlogram? Not actually we studied in theory class. It's a graphical representation of correlation. We can represent the correlation in the form of the graph. So that can be used for the PowerPoint presentation or something. Okay. And in this library, we'll draw the graph. Okay. The library is mainly used to draw the correlogram.
Sir, in that case, I would like to give one example. There is a tool that we use in our extension, participatory research analysis, participatory rural appraisal, PRA technique. So in that technique, we will see the relationship of the villagers with the institutions, social institutions. So we use a tool called as Venn diagram.
Yeah, I remember.
So can that also be possible
Yes,
to assess this?
Yes.
Okay.
Okay, so what I'm trying to say is ggcorrelog is the library for creating a correlogram in R, but it got another purpose. It will also create a p-value matrix. So if we got the p-value matrix means I can identify which correlations are significant or not. Okay, so that's why the line number 262. For that you need to call the library ggcorrelog first, then core pmat, that is the function for calculating the p-value matrix. So remember, core is the function for calculating the correlation. Core underscore pmat is to get the p-value matrix. Inside that, what is CO double R? CO double R. So COR.
Correlation.
It is your correlation matrix. Because we already call it as COR. So that should be inside the pmat matrix. Now followed by 3. What is this 3?
Judges 1, 2, and 3.
No, no. It's decimal. Because we started with a rounded function. So you need to round it into 3 decimals. Okay. So please run this 260. 260 and 260. Now you can see that. Let's compare these two matrices. So this is the correlation coefficient and this is the corresponding p-value. Now here you can see that there is no any correlation to the significant. Can you see that? If it is less than 0.05, I can put a single star. If it is less than 0.001, double star. Like that. Okay. But in this case, all the p-values are above 0.05, so we can't say that any correlation will be there. Okay. Then coming to the correlogram. So for that, first I am going to run 264 to 271. Then I will explain each. So you can see that. So this diagram is known as the correlogram. Okay. It's a beautiful diagram, right? Now look at the legend. What is this legend? +1 to -1. That represents the range of correlation. Now, see, as the intensity of red is more indicate what? There should be strong negative correlation. Similarly, intensity of green indicate high, strong positive. Now you can look at the diagram. Now this is very simple. But when you have practical situation, you have more number of variables here. So with the aid of this diagram, we can easily identify which one got the highest strong and highest negative correlation. Because in this case, we already know that J2 with the J3 got the highest because it got the high intensified green. And coming to this one, because as we moving down towards the 0, the intensity of green is reduced. Now I am coming to this program. Okay. The function is GT to draw the correlation. Inside that, first one is you have to call your correlation coefficient matrix. In this case, it is CO RR. So we already calculated. Okay. Then HC order, that is hierarchical order, should be true. Hierarchical order means either it should be in a highest to lowest position. That is the hierarchical order. Next one, type equal to lower. There you can see that there is an upper diagonal and lower diagonal. So we can actually flip this diagram. How? Type lower means you will get the lower portion of the graph. Upper means this graph is flipped into the opposite direction. That is the type. Like LAB. What is LAB? It's the label. Okay. Then LAB size.
3.
This label size. Okay. Then method. Circle. Because you can see that each value is represented by circle. That is the method equal to circle. Then we can define your own colors. Now the advantage of R is there is an infinite number of colors are available. See which colors I am using. That is command 2. But we usually prefer the color. We usually give it as red, blue, green. You can see thousands of red variation in the like the tomato, chili, whatever may be. Okay, so you can go for customization. See green. This is spring green, forest green, dark green, light green, steel green. There are many. Okay, then title. So that will give you the graph title. The last one, GGT. So theme I am giving the black and white. That's why the entire theme is black. So in a way, you can customize everything. The title, the color, the shape, the axis title, label, legends, whatever may be, you can change. So that is the beauty of architecture. So that's all about the correlation and the correlation. Now, one last topic, that is the Kendall. Now, what's the difference between Spearman and Kendall? At least two differences. As I told you, both these methods are used in the case of categorical variable. But why we have two? Why can't we simply rely on Spearman? Okay, times. There is a separate equation for Spearman. The difference is you can deal. It is a similar to correlation means every time we are looking for two variables at a time. Okay, X and Y. Okay. But in Kendall means if there are more than two variables, you can simultaneously take in for the relationship. That will give you a single value whether all the variables are related or not. So we usually call it as Kendall is for testing the association between the variable. Association between the variable means the main difference is it ranges from 0 to 1 only. There won't be any negative value. Whereas Spearman it is -1 to +1. 0 to 1 means 0 means there is no association between the variable. 1 means there is a strong association between the variable. Okay. Now I already written everything about the Kendall over here. It is a measurement of association between the right face of variables. And we have to place important data set. So here I am taking the same example. Instead of cooking, we have a singing competition, and the 4 judges give a mark out of the 10 competitors, and we have to check whether is there any association between these 4 judges or not. You can also perform the same data for sphere 1 also because it's a ranked variable. So, but in that case, you can check whether they are related or not. But in this situation, you can say whether there is an association between these. Okay. Please import the data. Sheet 3. Data management. Sheet 3.
Okay.
Okay. So this is my data. In sheet 3, we have data file. So how to prepare the data is column wise you have to enter the different ratings for judges. So we have 4 judges named it as A, B, C, D, and each participant score is corresponding to each. So that's how we prepare the data. It's exactly same as in the case of sphere. So there won't be any difference in the preparation of data. Okay. Now the function available for Kendall is Kendall W. It is available in a library known as the Desk Tools library. So please call the library Desk Tool. Among that, Kendall W is the function. This is my data. Correct equal to true and test equal to true. Okay. So listen, there are 2 things. Correct equal to true means if there are tie values are present, you need to correct that value. So that's why correct equal to true argument. Next one, we need to test the significance of Kendall test. That's why test equal to true. I'll repeat once more. Kendall W is the function for calculating the Kendall coefficient. As to data management is my data. Then if tie values are present, automatically it should be corrected. That's why correct equal to true. And finally, I need to give a significance for this test. That should be test equal to true. Okay, so at the end you will get the Kendall value, that is 0.69. Here is also we got a p value is significant. So Kendall coefficient is significant. And what is association? It is nearer to 1. That is 0.7. So we can say that there is a slight association between the 4 values. As it approaches to 0 means there won't be any association. It is nearer to 1, that is 0.7 means we can say there is a slight association.
ഇന്നിവിടെ പറയും സ്പിയർമാനും കെൻഡാലും എന്തുകൊണ്ടാണ് എക്സാമ്പിൾ വെച്ചിട്ട് പറയുന്നത്.
Okay, so in the case of the same data set, we have a competition, we have 4 judges here. In Spearman, what we actually do is every time we will consider 2 judges, whether judges A and B having any relation or not. A with C, A with D, B with C, B with D, C with D. So there are 6 set of correlation. That's actually true in Spearman. But here, I am not for the pair-based combination. Overall, these 4 ratings having any relationship over. That's why we got only 1 value. Whereas in the case of Spearman, we got 6 value because there are 6 combinations. So that is the difference. So overall, you are checking is there any association between the ratings and changes, Kendall will be good. And if you are going for individual wise, Spearman will. Because both you can apply in the case of categorical or historical. So that's our session.